Hello, Mr.
We
Ji,
are
good
go at live.
afternoon. Mr. Ji,
हाँ
good
भाई
afternoon.
शर्मा जी आवाज सुनाई जा रही फोटो हाँ
Good
नमस्कार
afternoon, good
नमस्कार
afternoon, good
शर्मा जी
afternoon. I'm there to welcome you.
हाँ तो
Sir, we will be live, sir. We are going to live, sir.
Start.
A very warm good evening to everyone. I am delighted to extend a warm welcome to our guests and audience on behalf of Rewa Engineering College. Since 1964, our institution has stood a pillar of academic excellence, boosting NBA gradings across three branches, nurturing talent through the both UG and PG programs. The Alumni Circle, Hirak Jayanti Talk
Hello,
Series,
hello.
a collaborative initiative by our training and placement cell, REC Pedia and Alumni Association. This series aims to empower students and faculty members alike through engaging lectures. It provides a platform for innovation and mentorship within our campus. Today, we are privileged to have our guest, Honorable Alumni Dr. MP Mishra Sir. We are thrilled to announce that Dr. MP Mishra Sir, a distinguished graduate from REC Rewa, will be gracing us with his insights on powering tomorrow, inspiring today nuclear energy. Inspiration of every entrepreneur, Bill Gates said that whether you like it or not, nuclear power is the future. So let us come together, open our minds, and embrace the opportunity to learn, to question, and to envision a future powered by clean and sustainable energy.
Good evening, everyone. On behalf of Rewa Engineering,
and inspiring today nuclear energy. Please join in welcoming Dr. MP Mishra sir.
Thank you, Niharika. Sanevas, can you please start presenting the slides? Over to you, sir. Mishra, sir.
Hello, Makhanji. So, may I start now?
Yes, sir, please.
Yes, sir, please.
So, dear alumni and students of Rewa Engineering College, it is a great honor for me to speak before you. Today is a special day for us as we all are celebrating National Technology Day, the day when whole world was taken by surprise. May 11th, the day successful nuclear test, namely Operation Shakti at Pokhran 2 in 1998. It is just a coincidence that my talk is coinciding with this day, and I am glad that the person who was instrumental in this program is attending this meeting and he is here. So thank you. I am not disclosing his name because of security reason. He is present here and probably at the end of session he will discuss with you. He is a gold medalist from 1973, our Rewa Engineering College, Padma Shri awardee in 2017. So he will talk to you after session is over. And then you had already 6 speakers, distinguished speakers before me, covering different areas of job opportunities in various fields. Friends, when we were studying in late 60s, we had no proper infrastructures in our college, no facilities were available. Our buildings were not ready. 2 years in science college, 1.5 years in BED college, and then final year we moved to engineering, our building. And we used to do mathematical calculations with the log tables and slide rules. Today you have calculators, and even calculators are obsolete. Now you have all the things on your phone. When we were studying steam engine, we have not seen even a steam engine those days because Rewa, there was no railway station. Now anyway, steam engine is the history. Now you can see only in some museums or in some hill stations. We used to see our job opportunities in newspaper. Nowadays you have internet, computer, so you are much better, well informed. With these few words, I will come to my subject of talk today. But before that, I have received 2 messages from our senior colleagues. One from 1970, which 𝐶𝐫 𝐷𝐼𝐻 has sent that indeed I will miss the session as I am taking MBA classes for executive PG program HRM at TISS Mumbai. All the very best, kind regards, GS Baveja. He is from our 1970 batch, our senior. And our Dr. V.K. Sutrakar, who has arranged this talk, he is presently in Europe. So, sir, I am at Europe, will try to join. Wish you a good luck and have a rocking session. With these few messages, there are many more messages, but I am now not going to that. I will come to my topic, powering tomorrow, inspiring today, nuclear energy. So next slide, please. So in my talk, I will giving brief introduction of nuclear energy, then why we need nuclear power, why then fast breeder reactors, why it is inspiring, trends and challenges, job opportunities in DAE, how to prepare for interview, but mostly I will be on the mechanical side because I basically mechanical man, and then conclusions. And here in the picture what you are seeing is Asia's first nuclear reactor in 1954 went critical Apsara in BRC, and now it is upgraded in 2017 and still is working. So that is the from viewing gallery you are seeing this Apsara reactor. Now please go to next slide. This program was conceived in 1954 by Homi Jahangir Bhabha, the father of our nuclear energy program, to meet our country's energy and security demands. Today, we have 7,480 megawatt power generation. 23 reactors are working, operating. And in another 5 to 6 years, we want to triple our capacity to 22,480 megawatt by 2031-32 in a progressive manner. Now I'll give you a brief introduction of what our Department of Atomic Energy and what establishments. So our Department of Atomic Energy has 6 research centers. The main is Bhabha Atomic Research Center in Mumbai. Then Indira Gandhi Center for Atomic Research, Kalpakkam, which is mostly dedicated for fast breeder reactors. Then Raja Ramanna Center for Advanced Technology at Indore, Variable Energy Cyclotron at Calcutta, and then this Atomic Mineral Directorate Exploration and Research in Hyderabad, and the Global Center for Nuclear Energy participation is in Bahadurgarh. Sorry. Next. Then 3 industrial organizations, Nuclear Fuel Complex Hyderabad, which is making nuclear fuel for our reactors, and they are also making stainless steel pipes and cladding material. Heavy water.
Close the door. Close.
Heavy water.
Close the door.
Reactors, pressurized heavy water reactors, we are using heavy water as a moderator and coolant. Then Board of Radiation Isotope and Technology, they supply radioisotopes for various industrial application and hospital use. Then 5 public undertakings are there. Nuclear Power Corporation of India Limited, that is, they are operating all nuclear power stations. Then Bhavani, that is at Kalpakkam, where PFB or prototype fast breeder reactor is coming, second stage of our nuclear power program. Our Prime Minister Modi ji has visited recently and witnessed the fuel loading and just before this election. Then ECIL, that Premier Institute in Electronics, and UCIL is the Uranium Corporation of India Limited, Jadiguda, and Indian Rare Earth Limited, Mumbai. Then 3 service organizations, that's Directorate of Construction Services and Estate Management at Anusartinagar, Mumbai. DPS is a Directorate of Purchase and Stores. They do mostly purchase and purchasing our equipments and materials for our atomic energy use. And General Services Organization is again a common services like township management, hospital, transport, etc. Then we have 11 grant and aid institute, the main, this Tata Institutes of Fundamental Research, Saha Institute of Nuclear Physics. Tata Memorial Center is a premier hospital for cancer treatment. Harish Chandra Research Institute at Allahabad, Institute of Physics. NICER at Bhubaneswar, Institute of Mathematical Sciences, Chennai. Indian Plasma Research in Ahmedabad. �𝐿𝐻𝐵 Bhabha National Institute at Mumbai. And then DAE and Mumbai Consortium is there for basic research. And that atomic energy schools. This atomic energy establishment is school where your Parag Agrawal, that ex-CEO of ex-tutor, now it is X. He is from this school, and also Shreya Ghoshal, the playback singer, is educated from this atomic energy establishment schools on Shakti Nagar. And Parag's Agrawal's, in fact, father joined same times when we joined in 1971. This is just for information. Then we have two boards of nuclear research in the basic sciences or extramural research in nuclear and allied fields and mathematics. It's not full-time, where part-time people can do some research. Next slide, please. Here you can see all our nuclear power stations and research establishment located throughout the country, spread in this. All operating reactors are there in many places like Kalpakkam, Kudankulam, Tarapur, Rajasthan, Narora, Kaiga, Kakarpara, and also under construction in many of these places. And there are some planned reactors for which Parliament has already given approval in principle, but negotiations are underway like Jadpur in Ratnagiri and Kobada in Andhra. Next slide, please. So this is just a typical view of pressurized heavy water reactor program. You can see that inside the dome where you do reactor core, control rod, and other things. And outside you can see turbine, condenser, and alternator is like any other thermal plant, power plants. That is almost, this is just for introduction. And in fast breeder reactors, we need additional safety features. So we introduce one more additional heat exchanger in between. Otherwise, layout almost similar to that. Next slide, please. So now why we need nuclear power? It is a key to combating climate change and reaching net zero. India has committed to net zero carbon emission by 2070. It's another 45 years. We have to reduce the carbon emission. And next slide, when you go, you will see that who are the main carbon dioxide emitters. And nuclear energy is also safe and reliable. It is not depends upon wind direction or wind, or it is not depends on whether sun is rising or the night is there, because you need for wind and solar, you need a storage facility. Whereas nuclear power, you can get uninterrupted supply throughout the 7 into 365 days in 24 hours. So there is no restriction of whether sun is there or cloudy day is there or is windy day or there is no winds. So that is advantage here. And it is a very clean energy. In fact, nuclear energy in 1 kg uranium, we produce only 30 grams of waste. This after 60, 70 recycling, reprocessing, and reusing. 1 kg uranium is generating only 30 grams of waste. There is no waste otherwise in nuclear energy. So that I want to make it clear. Then countries which use nuclear and renewable energies together, they are most successful in combating climate change. Then atomic energy also supplies radioisotopes for hospital, industries, all radiography and all those things. And then also for food preservation and irradiation, spoilage of marine fruits, spices, and enhance the shelf life of food products like onions, mango, etc. Next slide, please. Now I was telling to you that coal and gas, biomass, they are the most emitters of carbon dioxide source and polluting atmosphere. Whereas you can see nuclear energy and wind energy and hydropower, these three are the least polluting. You can see the percentage of carbon dioxide released from this. So coal is the actually maximum polluting, so that's why we are planning to bring it down by 2070. Next slide, please. Another advantage of nuclear power, you can see that capacity factor. So solar and wind energy are the least capacity, you can say, because they need a storage facility for them when there is a night and other thing. Whereas nuclear is the highest capacity factor, 92%. In fact, yesterday night, I got this message, and I am glad to inform you that 𝐶𝐫 and 𝐶𝐽𝐵 power stations are operating 120%, 115% from their rated capacity. In fact, 𝐶𝐫 is rated for 1000 megawatt. This is generating 1018 megawatt with 𝐶𝐶 power station 1 and 2. And 𝐶𝐽𝐵 also is designed for 220, so that is generating, I think, 238. So more than 100%, 115, 120% in the summer they are generating. So 𝐶𝐽𝐵 and 𝐶𝐼. So that is the advantage of nuclear power station. Now go to next power slide, please. Now you can see here, nuclear for 1 gigawatt nuclear power station, you need just 1 square kilometer. Whereas solar energy, you need 45 square kilometer, and for wind energy, you need 270 times land requirement. See, comparison where nuclear stands. So and solar and wind also, then you have other wind also have environmental and wildlife problems. Their safety is in danger where your wind power are situated. Now coming to next slide, please. Why we need fast breeder reactor? India has very small amount of uranium resources, but we have quite a large amount of thorium. So to utilize that, we have drawn up 3-stage nuclear power program. And the first stage, we use natural fueled pressurized heavy water reactors, which most of this present generation operating reactors are, except Tarapur, I think. All are pressurized heavy water reactors. Then second stage, fast breeder reactor, where we are utilizing plutonium. Slide, please. Slide, can you make it bigger, please?
Ram sir, can you please?
Previous slide.
Ram sir, you're sharing your Ram sir, you're sharing your screen. So could you please turn off? Shanavas, please.
Previous slide, please.
इसमें साउंड क्यों नहीं आ रहा है देखते हैं।
Previous slide.
Ram sir, please stop sharing. Shanavas, you can just remove, sir.
Previous slide. Slide.
Shanavas, pin.
Sir, it is visible now.
Previous slide, please.
No, it is coming small. Please make it big. Pin your slide, please. Or reshare. Shanavas, please reshare.
Sorry. Pithawaji and Makhanji, I think this is a slide.
Shanavas, please reshare. Stop sharing and reshare.
Slides. Or you want me to play?
Just a minute, sir.
Yes, it has come. Okay. So, first feeder reactors, we are utilizing plutonium received from, first is a pressurized heavy water, and thorium we use in the blanket materials, and from second stage we get uranium-230D. So in third stage, advanced nuclear power station using thorium. Actually, thorium is going to be game changer in our atomic energy power programs. Now, next slide. Yeah, here you can see 3 stages are shown. First stage using natural uranium with pressurized heavy water reactors, where you can have total generating capacity around 328 gigawatt years. So means if you are using 10 gigawatt or 20 gigawatts, you can go for 30-40 years. But in second stage, when you can use plutonium from first stage and thorium you can put in blanket. So the second stage you can go up to 42,231 gigawatt years. And from here you will get uranium-233 and thorium again. So you can go about 1,55,592 gigawatt years. So it's a substantial 100,000 times increase by using thorium in advanced heavy water reactors. Okay, next slide, please. Why it is inspiring? So it is inspiring who would relish to challenges in frontier areas of science and technology. You know, BRC is a premier institute where A to Z specialization is available. You ask for anything, you will get the answer from the BRC. It is inspiring you would like to be part of an expanding program of nuclear reactor accelerators and fuel cycle technologies. It is inspiring you would enjoy pursuing innovative research in engineering, physics, chemistry, biosciences, and geology. After the first nuclear test, namely Operation Smiling Buddha on May 18, 1974, sanctions were imposed on us. Thereafter, we have to develop our own indigenous technologies. Today, we have mastered our complete fuel cycle technologies. And after May 11th and 13th, 1998, nuclear test operation Shakti, we have become a nuclear power state. I am glad today person is here and we will interact with him after this session. May 11th is also celebrated every year as a National Technology Day. That I have already told in the beginning. That is an honor for us, our scientists and engineers, those who are working on this. And it supports our national security. Next slide, please. Trends and challenges. So to fulfill the net zero objective, it's highly recommended that seriously considered to replace aging thermal power station. I think 𝐍𝐼𝐷 must be here listening from somewhere. So thermal power stations, those who are old enough, they can replace with a small modular reactors. And to achieve this, we have already public-private partnership. Two is being considered. And NTPC and the Nuclear Power Corporation already working towards this direction. 𝐍𝐼𝐷 has already mentioned in his talk earlier, 𝐶𝐞𝐫 in Madhya Pradesh and Banaswara in Rajasthan. 4 reactors are coming in Banaswara, 700 megawatts, all indigenous design. And 2 are coming 700 megawatts at 𝐶𝐶𝐞𝐫 in Madhya Pradesh near Khanda. And now Reliance Energy, Adani Power, Vedanta, Tata Power too have shown their interest in nuclear power. Now only Atomic Energy has opened its door for private participations, but nuclear fuel will be still in our control, because the nuclear part is that which is sensitive. We cannot give to private parties. Next slide, please. And now it is proposed to go for a small modular reactors, roughly up to 300 megawatts, which you can fabricate in factories and assemble at site. And even some countries now they are talking about micro modular reactors. Less than even 100 megawatts, you don't need transmission lines. You can just on a remote village, if you want to electrify, you can just install that micro reactors. In addition to nuclear power can also be used for desalination plant and production of green hydrogen, that is a fuel for future. So desalination plants like places like Chennai, we have a shortage of use for drinkable, and hydrogen is a fuel for future. And Tata has already introduced a hydrogen car Mirai, and our Nitin Gadkari, Transport Minister, is having already one. Next, please. Job opportunities in DAE. So now you have seen so many places, nuclear power station, research establishments are there. It's a vast scope for engineers, physicists, chemists. NPCL is almost annual intake of scientists is around 400. I think so recently they have advertised, and I think so that April 30th was the last date for, I think, for filling the application. DRC training school, I think so annual intake is around 300 scientists. I think so Pitwaji may correct me if I am wrong. I think it's around, earlier they were taking only 100, but now, and in addition, they have a direct recruitment, almost the same numbers. And quite a good number of people are retiring nowadays, including scientific assistants, and diploma holders also get promoted to scientific officer rank. And I think IGCAR alone about 100 vacancies are created by retirement of officers. And if you take BARC and other establishment, it will go to 400, 500, 600. In addition to above, there are direct recruitment based on need. Next slide, please. Now, how to prepare for interview? So myself and Ranaji, we have opened the gate for you people. We were the first from Rewa Engineering College from 1971 to enter BRC. And then 1973, 𝐾𝐫 got selected. And please note both Ranaji and 𝐾𝐫, they are gold medalists from 1971 batch and 1973 batch from our Rewa Engineering College. And then I will tell you some basics. Mechanical engineering, I think mostly it will be interesting for mechanical engineering students. How to prepare for interview if you have to design a shaft. So, or a boiling curve or iron carbon diagram. Just go to next slide, please. This is just a simple shaft in torsion connected to motor. It's mounted in two bearings and other side is a driven machine. So you can just, in your group, there are mechanical engineers here, mechanical students, some of them you must be having. So you can pi by 16 d cube of s, you can torque equal to, you can apply that formula and find out the diameter. But now here is a twist. Unless if ratta maar ke gaye hoge to kuch nahi hoga. Unless you are fundamentally clear, now I will tell you, the shaft ke center mein you mount a flywheel, connect with a belt, and connect another load driving machine perpendicular to this. Bending is introduced. So torsion and bending now. So how you design, you calculate bending moment, you calculate torque, and then T square by M square under root that equivalent torque. Then that you apply and then calculate by pi by 16 d cube of s. Now there is further in this they can ask how you derive this formula. What is the assumption of pure bending, that material should be homogeneous? Material is subjected to within the elastic limit. And now if they want further drag, you suppose this solid shaft is melted. And then you make a hollow shaft out of this shaft of same diameter increase, then ideal length is same, weight is same. So which shaft will be a stronger, hollow shaft or solid shaft? So these are the some questions which they can ask in shaft design itself. So unless you are fundamentally clear, you cannot answer all those things. Next slide, please. Same thing is in the boiling curve, where you have natural convection, nucleate start forming, and then transition is there from then film boiling start. So for most efficient for design point of view, the nucleate boiling, which is considered the most efficient for heat transfer point of view. Next slide, please. This is a iron carbon diagram, famous iron carbon diagram for any mechanical engineer should know. And what is the role of carbon, what is steel, what is a cast iron, what is alpha ferrite, what is a delta ferrite, what is austenite, what is a phase for alpha ferrite is a BCC, austenite is FCC, what is their latest parameters. All those things, these questions can form, so you can Good. With this, I'll go to next slide, please. So, in conclusion, before conclude, I want to tell you that in March 4th, 2024, IIM Ahmedabad has conducted this meeting to review that what is our preparation towards net zero by 2070, wherein Dr. Ajay Sood, our principal scientific advisor, then our Niti Aayog member, and then Dr. Kakotkar, Dr. Mohanty, Mr. Chetal from our IGCAR former director, NPCL, and renewable energy. All these people have met in Vigyan Bhavan on March 4th, and they have reviewed that what is our preparation for reaching to net zero by 2070. So there is no silver bullet to achieve the net zero. Transition needs multiple pathways to be adopted with coexistence of myriad technologies in our energy basket. All thermal, wind, solar, nuclear, all combined is not just a single. And coal projected to continue until the next 2 decades as the backbone of our Indian energy system. And net zero is not possible without substantial nuclear power and renewable energy generation by 2070. And for this financial requirement by 2020 to 270 is in the tune of 150 to 200 lakhs crores. Next. So I would like to end my talk with the following message that no power is costlier than no power. No power without nuclear power, whether it is for energy or for the national security. And no climate changes can easily be addressed without the induction of nuclear power in our energy basket. So with this, I think I have sent one video clip, a small clip. If you can play that, it will be helpful. So Vaishnavi, can you play that?
Yes, sir, yes.
Yes, this is our Operation Shakti Pokhran on this day, 11th May 1998. Please, play.
Today, at 15:45 hours, India conducted 3 underground nuclear tests in the Pokhran.
1998 भारत के पश्चिमी छोर पर राजस्थान के पोखरण में परमाणु परीक्षण किया।
That's all. Now our talk is open for discussion, but please restrict your questions only related to technology and preparing for. Please don't ask any question related to national security, as we are working in sensitive areas. So we will not be able to answer, and we will not discuss other than what is available in public domain. And Padmasri, Chandrakant Pithwaji is available here. You can interact with him that how he was camouflaging himself at night with Abdul Kalamji and Chidambaramji at night, avoiding US satellites at night and doing the job. So you can get all the inside details from Pithwaji, but he is not due to security because you are making in YouTube. So I don't think that more details we can disclose on these things. This is going all over. I don't know whether Rana ji has joined or not. He is also in this 15. No, I think. Rana ji, I think, has not come here. So, anyway, now your questions, if you have anything, go ahead.
Thank you for the wonderful session, sir.
I am not able to hear your voice clearly.
Thank you for the wonderful session, sir. We have bombardment of questions in the YouTube live chat. So I would like to request Niharika to read aloud, sir, narrate questions to the sir.
Okay, sir. So there we have got several questions in our comment section, in our chat section. But as you said, we have a limit of time. We have lesser amount of time, so we will only focus on some of the important questions that the majority has asked. So first question I am saying that is, what are the biggest challenges to expanding the use of nuclear energy? So what are the biggest challenges to expanding the use of nuclear energy?
Challenges are there in many countries. In our country, we are not facing but challenge. One challenge is their public acceptance, because it still is there in the mind of people that atom bomb of Hiroshima and Nagasaki. But peaceful use of atomic energy is there in every health, food, and many places. So one is a public acceptance. Even in India also, in some places like Kudankulam we faced earlier some. So that is one challenge. From technology point of view, we don't have much problem now. We have developed our own infrastructure is available, road, grids, and I think industries are well equipped. And in fact, 10 reactors we have given in fleet mode. Earlier, industrial people are complaining that they make a special arrangement for nuclear equipment fabrication, and after that they lie idle. So now we have given fleet mode, 10 reactors at one go. So every year, at least, like for example, one or two heat exchanger they will be delivering every year. So they have work for another 4 or 5 years, and for your kind information, in another 4 or 5 years, we are going to triple our nuclear generation capacity. Another, people were thinking earlier that waste management is a challenge, handling nuclear waste. But as I told you that 1 kg uranium, after 60, 70 reprocessing and recycling and reusing, only 30 grams of waste is generated with 1 kg of uranium. And that too, that is you can say 100 to 300 years half-life. So they are stored in deep depositories underground and put under observation. And after 200 years or 100 years, their radioactivity will as good as like in uranium mining, you do uranium mining. So these are something which challenges I see. Otherwise, there is no other challenges from technical point of view.
Okay, thank you, sir. We have one more question. One more question, sir. Can nuclear energy live up to its promise of powering a sustainable future? Like, can nuclear energy live up to the promise of powering a sustainable future?
Yes, 100%.
Sir, can we take one more question?
Yes.
Sir, can we take one more question?
Yes.
Okay, sir. Sir, how can we ensure the responsible management of nuclear waste for future generation? As you said, sir, that yearly we only create about 30% of the waste. So question is arising from here, how can we ensure the responsible management of nuclear waste for future generations?
No, I am not clear your question.
Okay, sir, I am repeating one more time. How can we ensure the responsible management of nuclear waste for future generation?
See, no energy sources are free from danger, but coal, millions of trillions of tons of carbon dioxide you are inhaling. So coal also have this thing, people are dying of asthma and this thing. Nuclear energy is categorized as one of the most clean energy. And nuclear energy has a well-established clearance system. Atomic Energy Regulatory Board is there that is independently working outside this review of DIE. And each and every stage they monitor, even for starting the reactor, at least 10 clearances and 20 clearances are given is phased manner. Once it becomes critical, once it becomes 10%, when it becomes 20%, 30%, and like that. So there is a well-established monitoring and control system. I think, Prithviraj, you would like to add something on this?
I think the question was related to nuclear waste, if I'm not wrong. You wanted to know. So it is sustainable, yes. The third, when we use thorium and plutonium in second stage, and then thorium, uranium-233, it will be sustained for many years. That is one part. But the question was related to nuclear waste. What is nuclear waste? Whatever we use in reactors, the fuel is we take it, reprocess it, and all useful material like plutonium and unused uranium we take out. And whatever material is left, that is a radioactive material. That radioactive material is the main thing which may be radioactive for many, many years, maybe hundreds and thousands of years, or sometimes millions of years also. So in that also, what we do, there is a process called vitrification of nuclear waste management. In that, this waste, again, there is a low level waste, medium level waste, and high level waste, and solid waste and liquid waste. There are various processes of this thing, but main thing is the solid waste. So solid waste, we do the vitrification. In that, what we do, this is melted along with the glass, and this waste, nuclear waste, gets trapped in the glass matrix. And you know, glass cannot be leached by any material. No acid, no water, nothing. And that is vitrified thing is put in the molten thing is put in the steel container, welded, put in another container, steel container, again welded, and this whole thing goes inside the earth and is stored there for many years with cooling, proper cooling. So even in the future, there is earthquake or something is there, it cannot be leached, it will remain there and it will not harm anyone, because it is whole radioactive is trapped in the glass matrix. So that is one thing. And same thing is, I'll just add, when we had conducted the underground nuclear explosion, so it was in Pokhran, and that full of sand, and glass is made by sand. So the temperature is so high, millions of degrees, when it explodes, that whole sand gets melted, converted calm, and all radioactivity gets trapped there, and it cannot be released. So it is automatic vitrification, natural. So I think I answered your question. If anything more is there, I can add.
Yes, sir. Thank you so much for this knowledge. Yes, sir. We are done with the Q&A session. Tanisha, do we have left with other things, or can we move to vote of thanks?
I would like everyone to turn on their camera so that we can get a snapshot for the memory. Everyone, please turn on your camera. Shanavas, just inform me when you are done.
राम शरण जी कहाँ गए थे?
Niharika, please proceed.
Thank you, Makan ji. Thank you very much for coming. Only Rana ji, I could not see. He also promised that he will be coming. And I don't know whether he...
Okay, now team, we may proceed for vote of thanks.
Okay, ma'am. So thank you so much to all our alumni, be the member of REC Pedia and all the students who attended the seminar. We want to express our sincerest gratitude for your incredible session on student motivation. Your session had sparked a sense of motivation and determination within each of us to go in the nuclear energy field, and we are excited to take the lessons you imparted and apply them to our academic and personal life. Once again, thank you for sharing your wisdom and expertise with us. Your contribution to our seminar was invaluable, and we are truly honored to have had the opportunity to learn from you. With sincere appreciation and thanking you, Team REC Pedia. Yes, ma'am, you are.